Hey, Simon here, and today I want to talk about doing liquid simulations on really small scale. Note that my scene is set to none here to the length units and is not set to metric or the imperial. And my sphere is really small. This is defined as an inflow and it's defined to really small scale values, as you can see here. So this is the domain, and if we just simulate it now, you will see that nothing happens. And I don't know exactly why this is the case, but what I noticed is that when I use a cube and I define it even smaller than the sphere, let's see it like so, let's do it like that, just delete the sphere and define this as inflow as well, then it works better. At least we see something. It's not perfect, obviously, but at least there's something happening. And when the fluid sticks in the cube, like here, it might help to give it a little negative value for the inflow velocity. And when you rerun the simulation, now you can see that, yeah, this looks way better. By the way, another problem with non-generated liquid may be, let me do this here. Let's define this as just a fluid, for example, and do cylinder, scale it a bit down, and define it as obstacle. And even if you now delete the upper face so that the cylinder is open and maybe rotate it a bit so that the fluid shall flow out, right? Where's the domain? Now it may happen that nothing happens as well as in the first example. And the reason is that we forgot to set this to shell, because now the volume is taken into account as an obstacle and the fluid is stuck in there and yeah, it can't come out. If you define this as shell here, and now we run the simulation, let's see here, then you can see that it works now. It takes a little bit, but yeah, you see that the fluid now comes out and lands on the cylinder. So to see that better, here's the solid viewport rendering. Yeah, okay, thanks, that's all. Have a nice day.